It's crazy, yeah. It's very crazy. All right, here you go, gentlemen. Welcome. Hello. All right, absolute value equations. We got the title. Medina, here we go. Sorry about that. All right, absolute value functions. On your graph paper that I just passed out, let's go ahead and create a small number line, okay? Do it with me. On the graph paper itself. Okay? Yep, and let's put a 0 in the middle. Okay? Let's go ahead and put a -1, -2. Let's do a +1, +2. Let's just go up to -3 and +3 for now. All right. That's right. Here we go. Let's go ahead and draw a little stick figure above +3. Okay? And let's put a little stick figure above positive or -3. Okay? Let's say this is Mr. Munguia. Let's put Mr. M here. And Miss Medina? All right, Miss Medina. You got it. Here we go. Okay. So, watch this now. How far from 0 is Mr. Munguia? 3 units, right? So Mr. Munguia is 3 units away. Going to write 3 units. How far is Miss Medina? Same. But even though she's negative, she's still 3 units away. Now the point of absolute value is distance is always positive. So here's what I'm going to write underneath now. Watch this. The distance between any number and 0 is always positive. Say again. The distance between any number and 0 is always positive. Now, watch this. So when I say the absolute value, watch this now. The absolute value of 3, these bars are called absolute value. They mean absolute value. You've seen them before, maybe in middle school? How far is 3 away from 0? That's what this is really saying. If you see those absolute value bars, that means how far is 3 away from 0? Well, it's just going to be 3, because distance is always positive. Brackets would be more like this, like that. Absolute value bars mean how far is that number from 0? Well, distance is always positive. Look at where I'm standing right here in the middle, in the front of the class. The distance between me and Ortiz, I'm facing Ortiz about maybe 10 feet. The distance between me and Colliado, 7 feet. Me and Rio, look at me turn. Now I'm at Rios, maybe 8 feet. Medina, 20 feet. I'm turning now. No matter where I turn, the distance between me and object, whatever object, is always a positive magnitude. If you show me what a negative distance looks like, I'll give you a credit slip. Still positive. Like, look, here's my eyeballs and the floor. I can get a ruler. That's still a positive distance. Good try, though. Say again. Well, here's my challenge is this. Give me an example of distance being negative. Never mind. Just go back to sleep. Hold up, Medina. Hey, Caliado, relax. Well, the thing is, I'm trying to drive home the concept that distance between any two objects in space is always positive. It's never negative. Uh-oh. Yeah. Watch this. Well, it's still so going home from here? Well, how many miles is it from here to your house? It's a positive, though. It's positive. That makes sense? You just said that. Good try, though. Gonzalez, hit it. You get a credit slip. You're done with my class. Give me an example of a negative distance. All together. Boo. No, just kidding. Good try, though. Good try. But if you listen, I said an example of a negative distance. He never displayed that, hence, he doesn't get him. Are you complaining again? Cool. Here we go. Let's go. So, the distance between any number and 0, when you see that bar, that's just saying, look at the distance between 3 and 0 is 3. Watch this now. Going right. And, watch this. The distance between -8 and 0 is 8. Because distance has to be positive. Right. But rather, what I want you to do, though, Rios and everyone else, I want you to know that this means the distance between a number and 0. And understand, and understand why it's positive, because distance is never negative. And I want you to remember my challenge for a credit slip. No one was able to give me a negative distance. That's why these always represent a positive number. Now, almost done. You guys are doing good for Thursday. Watch this. On your graph paper. Okay, thanks, Caliado. Here we go. Example 1. Let's graph. Ready? Stay with me, Caliado. Let's graph f of x equals the absolute value of x. You guys with me? Adriana, you're with me, right? Get my graph paper. You guys grab graph paper in front of you. We're ready to rock and roll. Medina's with me? Guess not. All right. How do we graph? What's the first thing we should do? You're the man. Now what? Javier, you get an extra stamp for that one. Watch this. But instead of y, look at, we got function form, so instead of y, I'm putting x, f of x. Because remember, y and f of x mean the same thing. You should know that by now. Here we go. We're going to see if this graph is linear or not. Do you guys think this will be linear? Let's see. What's some good numbers, Gonzalez? Let's go -2, -1, 0, 1, and 2. I'm sorry? I'm sorry, Gonzalez. So let's go ahead and put these 5 values here. Negative 2, negative 1, 0, 1, and 2. All right. Looks weird. This is so easy. I trust you and I can actually do this in our mind. I haven't even had any coffee since the morning. I could probably still do this, though. All right, so wherever I see x, I'll replace it with the number. So what would be the absolute value of negative 2? You're the man. We do this in our mind. Absolute value of negative 1. Oh, my gosh. You got to be kidding me. 0, 1, 2. All right, let's graph these puppies. Is it going to be linear or not? Let's see. Here we go. Negative 2, 2. Negative 1, positive 1. We got 0, 0. We got 1, 1, 2, 2. It ain't linear. Watch this, though. It comes down. It makes this V, goes back up, put arrows. It goes on forever that way like that. Do that for me. I agree. Ladies and gentlemen, you have just beheld our first absolute value function we've graphed this year. Watch this. That bottom V part, this little point at the bottom, there's a special name for that. We call it a vertex. Go and write that down on your notes. So this is definitely nonlinear. Sure. Why it's not linear? Okay, so let's straight line from forever, yeah. Right. So linear is just a line. The word line is in the word linear. Okay, all right. So this is not a line, it's like a V. This is absolute value function, not a linear function. Now, watch what happens now. With the same graph, though, we're going to, on the same coordinate plane, in other words, we're not going to draw another x and y axis. Go and write example 2. We're going to graph f of x equals absolute value of x plus 3. Look at that function. Now,
when you say you could choose your own numbers, is it still going to get the same graph?
Yeah, always, no matter what.
5, 4, 3.
Right, because let's say 5. Let's real quick. If I put x for 5, what's the absolute value of 5? 5. So look at it would be 5, 5, and look at where it's at. Watch. 5, 5 is right there. There it is. It's on the graph. You see how the math works? It is. Watch this now. What's the difference between example 2 and example 1? Help. That's just a 3. That's it. All I did is same. Everything's the same. It's just I put a 3 right here. Watch. Look what I'm going to do now. If I want to graph it, look what I'm going to do. That table of values, out of here. I'm done with that. That's kiddie stuff now. I'm going to take the original function, and all I'm going to do is move it up 3. That's it. I took the function, the absolute value, and I added 3. What that does to the graph is it just raises up 3 units. So put an arrow, watch this, put an arrow from this function to this graph, the new graph. So you know that all we did is we shifted the old graph up 3 units.
That's what that plus 3 means?
Right. That's all we did. So if I ask you to graph that, well, just take the original graph and just move it up 3. What we do is we call this original graph in example 1, we call this the parent function. Go ahead and put an arrow, put parent function. Why do you suppose we call it the parent function? Okay, Colliado, then Valdez, go ahead. All right. You're on the right track. Valdez, give me some more. The original, and then this one is what? It's like a child. Exactly, this is a kid. So the parent is the black, the kid is the blue. Let me give you another kid. The parent's going to have another child. Ready? That was awesome. Munguia's a racist now. Watch this. Here we go. Watch this. Example 3. Okay, this is for YouTube. One more time. All right, watch this. Here's another child. F of x equals absolute value of x. Watch this. Minus 3. Valdez, what's going to happen? Where's the child? You get a lot of views for that one. Huh? You guys seen it? Thank you, Colliado. I know you do. So we got parent, we got children. The children look like their parents, which is like in real life. To one degree or another, you look like your parents. The children graphs look like their parents. They're just a little bit different. They're shifted. All right, watch this. Last one. Last one. Yeah. Yeah, example 4, last one for today. Ready? Watch this. Then we'll do our credit check. Example 3. My bad. Need more coffee. Where's my coffee? Starting to panic. Example 4 is, watch this, f of x equals absolute value of x minus 3. What's going on now?
You're just probably going to take the number that's x and subtract it.
Right, but without doing the table of values garbage, what do you think this child, the green child, will look like now? Is my question to you. I'm giving an extra stamp for whoever tells me. So look at, the parent is black, the first child was blue, the third child was red. What's the green child going to look like? Colliado first, and then, never mind. I thought you had your hand up. You had your hand up or no? Never mind. Extra stamp for someone to tell me what the child's going to look like, Gonzalez. You're going to lose your stamp for having that phone out. Good job. Good try. What's this green child going to look like? Remember, look at the parent was this. First child, look at plus 3, that was vertical shift up.
What if it's fake? It's going to be 0. Yeah, what if it's fake? You know why?
Okay, wait, hold on. So it's going to be, what do you mean by it's going to be 0 reals?
0 because there's no number higher than 3. And then I would say subtract it, right? Subtract it and then take 0.
So where would the child be? What would it look like here? Here's the parent, first child, second child. Where's the green child going to look? What is it?
Down syndrome upside down.
Hey, that was next week. You know, he's actually onto something. Next week we're gonna have a child that goes down. We'll call it Down syndrome, but that's actually not this one. But you're onto something. It's kind of funny you say that. Right. So this one is going to come out normal, but how's it going to look for an extra stamp? Anybody? Hold up. Okay, one more. Ortiz, hit it.
It being vertical, it goes horizontal.
Instead of going up and down, it's going left or right? Okay, where though? You're there. Hold on. We got this. Go ahead. We're -3, so right here. So the vertex will be there?
No, -3 going down.
Oh, so it's going to be like a Down syndrome, like you said?
No. It's going to be like a righteous. Sideways.
Oh, sideways. Okay, good try. Anybody else over here? I think that's Gabriela. Extra stamp. Okay, good try. I'll make it 2 stamps now. The child. What's this new child gonna look like? The blue child was up 3. The red child was down 3. What's the green child gonna look like? Good try. Good try. 2 stamps.
Sideways like this.
Good try.
Wouldn't it be
Going down or what?
Yes, sideways going this way.
Good try. Good try. I like that idea. Colliado he was kind of thinking the same way. Okay, hold on. Hold on. Watch this. Okay, hold up. Lavieta, let me get your idea right now. Give me a second. So, what's going to be at 5? The vertex, you mean?
Yeah.
Okay, the vertex will be at 5. Good try.
No, it's going to be at -3.
Good try. 2 stamps. Positive 3 or negative 3? Is it going to go up or is it going to go down? It's going to be like this or like this? Gonzalez got it! Watch this. Watch this. Put the vertex at 3. Same shape as the parent. It moves to the right if it's a minus. For some funky reason, we'll get into that Monday.
Is that how it is?
But look at. Yes. Right, so look at. The first child made sense. Look at. The first child made sense. If it's +3, you go up. The second child was outside the absolute value. It's -3, it goes down. But the -3 inside the absolute value, it changes to the right because of absolute value. And we'll get into why it behaves that way on Monday. What I'm going to do now, check this out. I'm going to beg you, I put 3 ring hole punches on your notes. You're going to put that in your binder. We're going to revisit this on Monday. Tomorrow's a quiz day and workshop day only, so we're not going to do any notes tomorrow. On Monday, you need to have this ready, these notes, because we're going to add to these examples. At this point, Valdez has his computer. Chromebooks are open. You want to do it, hold up, you want to do a credit check. You and your stamp sheet are going to bond together. You're going to figure out where you're at in terms of your 3 credits of where you should be. You should have 48 by the end of today. Grab those puppies. Yeah.